Ledge Runner Part 2. In the last lesson I showed you how the game looked like, and we created this boilerplate code, about 100 lines of code of boilerplate, and we need even more. We don't have the two buttons. Well, we won't do heavy stuff in this lesson. We'll do boilerplate code and maybe the animation of the player too. So let's start. We'll do game objects. Here we will create the player and the first ledge, and we'll also need buttons. So we'll need the button IDs so we can refer to those buttons anywhere in the code. So btn right for the right side of the screen, and btn left. Right will be 1 and 2 will be 2, well, left will be 2, and we'll create a virtual button. They call it a virtual button in AppGameKit. Add virtual button. So the first argument is the ID, btn right, and its X will be the right side of the screen, -50. So we'll do get screen bounds right, -50, and the Y will be 300, and its size will be 50. Let's see. What's the error? Oh, no parentheses. So that's the button, the right button. Let's do the left one now. Get screen left and +50. So now we have the two buttons. The click event will be in move here, but first let's create the actual player. So we'll create an instance of yPlayer, p as yPlayer, and we'll also return it. p.id will be player sprite. Player sprite. Let's just copy it so we won't have any typos or anything. Player speed, you know, the movement speed for the left and right. I found that for this game it was 0.1. You can play with it to make it faster or slower. I wanted this speed. So basically when the player So basically, when the player clicks left or right, this speed will be added to the x velocity, the velocity x, which I called speed x, which is the movement speed of left or right. Moving on. At the start, the speed x and speed I will be 0. Speed y will be 0. Vertical friction I found at 0.5 worked best for this particular game. So after we filled all of the player's fields, we'll create the player's sprite. p.id and the player img. This one, the ID of the img, the runner png. Let's see. So now we'll need to set the sprite map. The sprite map's dimensions. Let's see. So yeah, we'll need to get dimensions of one frame. Let's see. If I'm to guess, it's 1 to 8 on 1 to 8, like it says here. The width is 1280, but the height is 1 to 8. I suspect it's 1 to 8 for the height and width of a single sprite. Well, I don't suspect, I know, because I already coded this game and I know that sprite. So let's set sprite animation. p.id. We want the player sprite, this sprite, and width 1 to 8, height 1 to 8, and it has 9 frames. Sprite index, frame width, frame height, and frame count. So 1 to 8, 1 to 8, and 9 frames. Okay. And then I wanna scale the sprite a little. Let me show you what happens if we do new player. It will be very big. We don't want it that big. So I'll scale it by half on the width and height. There's also a way to change the width and height of a sprite, but you know, in this case you can just scale it. I don't want to measure pixels now, I just want to make it smaller. So sprite ID 0.5, 50%, 0.5, 50% again, and it should be smaller. Great. And that's it for new player. Another thing I want to do is I want to create a global player object so we can manipulate it anywhere. Global variable that will contain the player object. Okay, so there we have it. What else shall we do? I want to show you the animation, the actual animation, how I did the animation. Actually did it in movement. So when the player click the buttons, stuff will happen. Like the player will move and then the animation will happen. For now we won't do the movement, we'll just do the animation because that's easy and doesn't require too many explanation. Virtual button state, I think. Yeah, so if it's 1 it means it's down. Which virtual button? btn right. So when virtual button, let's do for the left. And then end if 2. Okay, it goes like this. When the virtual button is down, when you press it, whatever's inside here will happen. So let's see, first we'll have to check if the sprite is playing. If get sprite playing, which sprite player the sprite with the player's ID. You see why I created player here? So we can access it from anywhere and use it. So we need to check if it's not playing. So if it's playing it will return 1, if it's not playing it will return 0. So if player sprite is not playing equals 0, then we can play the animation. The reason why I do this is like if you press right all the time and you tell it to play the animation, it will reset the animation every time. So I want it to play the animation, finish, and if the button is down, play it again. So that way you'll have the running loop. Okay. Play sprite, which sprite player.id. So let's see, first is the frame rate. The frame rate was 15, and then start from 0, and we can do 9, but I did 1 for some reason, and then -1 for looping. If we did 1, it will loop here. Let me show you in the documentation, that would be the best. Sprite ID, the FPS 15. The start of my loop is the looping mode. So if 1 loop, if 0. Oh, okay. So from frame to frame. Well, I just remembered all of the arguments. So don't loop the animation. Start from 1 until -1. Let's see what's -1. -1, I think it's when it starts. Frame optional default -1. So -1 is like play until the end. Okay. We can now test it. So yeah, play sprite, the sprite ID, frame rate. If you need loop or don't loop it, loop is 1, don't loop is 0, start from frame, and this will tell you to go to the last frame, the 9th frame. But if we didn't know how many frames there are, which is not possible because we told it has 9 frames, so we know it's 9 frames. So it will go to the last frame if you put -1. Let's test it. It was right? Nope. We see a problem. It stops on the last frame. We want to return it to the first frame. That's an easy fix. Very easy to fix. Reset animation to idle. To its idle state. You know, the first frame. So we need to check if it's not playing. And we do this before any input. I think we have to put it before the inputs. Haven't tested it after the inputs. So it's one line of code. Set sprite frame player ID. That's the sprite we want to affect. Send it back to frame 1. If it's not playing, send it back to its idle mode. Maybe here you would want to play a different animation, like an idle animation or something. And then you would have to write different code here. When we'll get to it in later games, we'll handle it. But in this case, we set sprite animation playing 0, do idle frame or idle animation. You see it goes back to the first frame. Nice. Let's we'll need to get rid of the print for now so we can see the sprite. So to make it go to the other side, we will actually use the same code. But we will flip it using set sprite flip. So you can flip it horizontally and vertically. So flip player 0 horizontally and 0 vertically. Let's see what set sprite flip does. 1 flip it horizontally, 0 keep it sprite normal, and vertically. Sprite ID, horizontal flip, vertical flip. So let's see what happens when we do that. No, it doesn't flip. Okay. Let's change the horizontal flip to 1. Okay. It does flip to the other side and does the running animation and goes back to idle, but when we press right, it does not flip it to the other side. So we'll have to put flip in the right animation too. Then we'll tell it to flip it to 0, flip it back. And then the other side. Okay, it works. Perfect. So that's the animation. Let's see now. I've seen potential problem here. Very strange. Get virtual button state. For here it works when you hold it, it runs. And on the other side, when you release, it runs. Interesting. That's because the problem I told you about happened. We're trying to play it all the time when the button is down. We want to play it only when the animation finishes. So when the animation finishes, when get sprite playing, player sprite is 0, when the animate, there's, it doesn't animate, meaning it finished animating, or it doesn't animate, then do the animation. So this will ensure that the animation will happen only once the previous animation ended. Great. It works. So let's write some more boilerplate code for our movement. So when you press right, you increase the player speed X. You increase it by player dot speed. And when you press the left button to move left, instead of increasing, you decrease the player X speed by the player's speed. Well, this won't do anything because we don't set the sprite's X. We won't even set it here. We'll have functions for adjusting the X and Y that will check boundaries and walls and all that. Well, the boundaries will be checked inside boundaries. So yeah, we'll have to finish the lesson here. I will continue showing you more stuff in the next lesson, and if you have any questions, please contact me. And that's it for this lesson.